All right, in this video, we are going to go over lesson 1.1, and we are on the section about writing expressions to represent real-world scenarios. So in this example, we've got Ebony and Tamika, and they both love shoes. And when we're comparing the number of shoes Tamika has with the number of shoes Ebony has, you might use the variable S to represent shoes. And we know that Ebony has 4 times the number of shoes than Tamika has. Right here says Ebony has 4 times the number of shoes that Tamika has. So we can represent that as 4S, since 4S means 4 times S. So if we were to practice this a little bit, if Tamika has S pairs of shoes and Ebony has 4S, who has more? Tamika has S and Ebony has 4S. Well, which one is more? Ebony would have more because 4S is 4 times more than S. So if Tamika has 10 pairs of shoes, how many does Ebony have? So if Tamika has 10 pairs of shoes, and we know Ebony has 4 times as many as Tamika, we would do 4S or 4 times 10 because I know that S has to be 10 because that's how many shoes Tamika has. So 4 times 10 would be 40. So if Tamika has 10 pairs of shoes, Ebony has 40 because Ebony has 4 times more. Now, if I'm going backwards a little bit, this one says Ebony has 24 pairs of shoes, and I need to know how much Tamika has. So if Ebony has 24 pairs of shoes, so I've got 24, but Ebony's had 4S, and I'm trying to figure out, well, what does that S stand for? So I would do 4S like that. So 24 would equal 4S, and to solve this, I would need to divide by 4. And 24 divided by 4 is 6. So S would be 6, which means that Tamika would only have 6 pairs of shoes to keep that same relationship as Tamika, or as Ebony has 4 times more shoes as Tamika, because 6 times 4 is 24. All right. That's how we kind of use those expressions a little bit. Now, if we move on to this next one, this is a guided practice problem about Carter and Sullivan. You're going to go ahead and fill in this one and number 2. And then we get to some interpreting some real world scenarios. So this one says, by combining what we know about coefficients, terms, and translating mathematical language, we can write and interpret whole expressions that represent real world scenarios. So in previous courses, you've practiced converting the basic wording into algebraic expressions. So for example, we've got 3 more than A here can be written as A plus 3. So if John has 3 more classes than Adam, A plus 3 would represent how many classes John has. We might also be told that we've got an expression of $5.25 D plus $10 would represent the total cost of parking at the airport, and we need to be able to figure out or interpret what does that mean. All right, so D would be the number of days that we spend at the airport. So when we're working at this, we know that it would be $5.25 a day plus this $10 flat fee is how we would look at that. So the flat fee is whatever is being added or subtracted. If we need some extra help, there's this great video right here that you can take a look at. So if I look at this example number 1, so we're going to try to interpret some of these expressions. So you and a friend are headed to a fair, and the expression F plus 125T plus 10 represents how much it will cost you to enjoy the day eating food and riding rides. Before the variables are defined for you, let's try to make some guesses. So what do we think this F could stand for? Capital F. Let's see, I know that I'm eating food and riding some rides. Well, F Food starts with F, so I'm thinking that this F is my total food, the total food cost. And then little t, we could say, is the number of rides that we are going to ride on. So little t would be the number of rides. And then my $10 would be the cost to get in the park, or the cost to get in the fair. All right, so that's how we would break that down. We've seen the difference between the big F and the little t is we're going to use a capital letter when it's a total of something. So here I've got my total food, which is why I've got my capital F. But on this one, I've just got a plain old number, which is why that's a lowercase t, because that expression or that term isn't a total number yet. Kind of like how in geometry with your volume formula, it's the area of the base or the total volume for the big V, and the total area for the big B. And the H is just the height of the one item. All right, if we move on to example 2, all right, we've got a job babysitting Friday night, and you get paid by the hour, and the parents also left money to order pizza. All right, if your expression is 850x plus 25, we've got this term and my second term. This plus, all right, we've got the x that goes here, right? What do we think that x means? What do we think it would stand for? Well, if I'm getting paid by the hour, that means that that is something that's variable. It's going to change. So the x would equal the number of hours. And my $25, well, that is money left for pizza. So that was like thinking of it as the flat fee. So that's your pizza money. Okay. When we move on to questions 8 and 9, you're going to read the little scenarios and click on those little links for some drop downs. All right, if you have any questions about questions 6, 7, 8, or 9, just let me know.